Right. Sorry, my camera cut out there, I'm away again. Okay, so I've plugged those in. Okay. I'm going to turn it round, and now what I'm going to do is plug in the supply. And as you'll see, it should do something, hopefully. Let me plug that in. And the first thing it'll do is I'll go through a boot up, so hopefully this thing will show that. As you can see, the displays will do some strange things to start with, and then you'll get a load of nonsense. Ignore the screen at the back at the moment, that's plugged in, but it won't go to that, it'll go to this screen. Hopefully you can see that. As you can see, it's now booted up, and you've got a desktop coming up on the display. The LED displays have settled down, and you've got some information displayed on there, and you've got the power light on. And that if I move this a wee bit more, that's you basically powered up. So the first thing we're going to do with this is start the test program. So in actual fact, I think the best, well, if I start the test program, I'll do that first. So moving the mouse around, you can see at the top there's a test program sitting there, right? So you can either double click that, or you can double tap it, because it's a touch screen, remember. So you can do both, and then you'll hear it click a couple of times. The displays will reset, it'll come up with the version number, and then it'll settle down, and then your test program is now running. So from now on, the tester is actually running. This is indicated by a running dot over here, as you can see it. You might be able to see that dot running. That indicates that the probe is active and the tester is basically running. The other thing you should get, if I do this right, you see me as a zoom in. I don't know if you can see that. It should tell you in here, and this is the main sort of text box effectively, and it should tell you on there microprocessor type set to Z80. The address is loaded to 0000. This is all hex, by the way. The data bus is set to an input, and it says it's ready effectively. If you don't get that, turn it all off and start it all up again, because it's not booted right. The displays indicate zero. These zeros here indicate the address. It's a 16-bit system, so you've got 16 bits. So that's 0000, which gives you the 16 bits. It's all in hex. That is data if present, currently 0, and this indicator up here tells you which direction the data bus is in. So at the moment, when it's up, it means the data bus is on an input. When it's down, it's on an output. The bottom line is to do with the probe, and at the moment, because I've got no probe plugged in, it's not doing anything. These are dashes, and D indicates it's set to a digital probe, i.e. a logic probe, but it's a little bit more elaborate than a logic probe. So what we'll do first of all is we'll go through some of the just different functions what it can do. So hopefully you can see it with this screen here. I'll try and get it a bit closer somehow or other so we can get both in. Maybe that's better. Right, okay. I'm going to use a mouse on this, so you can see there's a mouse moving around at the moment. So hopefully that's fine. So down the bottom here you've got basically special functions. You've got 5 special functions, and you've got 2 other buttons down here. You've got a clear button. Basically that clears whatever's in that screen there. So if you got a lot of stuff in there and you want to clear it, you can just press that button, it will clear it. Help, that will come up with a lot of help in that screen. The help information is to do with the low-level commands that the Arduino will accept, because there is an operating system within the Arduino called, I've called it AOS, which is the Arduino operating system. So you can put low-level commands into it as well. Most of the time you can just do it with buttons, but if you want to do some clever stuff you can do that. At the top here is all these other buttons. So you can write an address, you can write data, you can read data, you can do a block write, block read, write IO, read IO, and then at the top also you've got the address bus you can set, the data bus you can set, bytes is how many bytes you want to read or write, etc. And you also got a port address as well if you want to use that. Port address doesn't always work on all processors. It's obviously set up as default to a Z80, and Z80s can use obviously IO lines, so that will work with the Z80. If you set it to an 8080, you probably find that won't work. The target is actually the processor you're using. So if you're using a board that's got a Z80 in it, you really want to set it to Z80. If you're using a board with a 6502, you click it to 6502 and it will tell you it's gone to a 6502 down here. The effect is immediate. As soon as you click that button, it works straight away for that processor. If you have it set in the wrong processor for the board, you'll probably get no results, or you'll probably get the thing locking up. So just be careful whatever processor you set it to. It currently only works for 8-bit processors, so Z80s, 6502s, etc. There's 3 supported. There's an 8080, which is the Space Invader ones, of course, Z80s, which are pretty common everywhere, and a 6502. These two definitely work. The 6502 should work, though I haven't got any 6502 boards, so I can't really prove it, but by rights it should be okay. So anyway, it's set to a Z80. It's all booted up. So for example, if you want to change the address, the tester wants, all the address and data is sent out on connector A. So connector A, and this is in the manual as well, it gives you all the pinouts. So the full 8 bits of the data bus are on connector A, and the 16 bits are on connector A. On connector B, you've got control lines and a load of other things. So if I wanted to set the address to say 1200, whoops, type in 1200 and click write address, and you'll see 1200 goes on the display, and it tells you it's set address loaded to 1200 hex. Of course, you can use upper lowercase, so it accepts A to F, obviously upper lowercase, and as soon as you click that and that 1200, that address pattern will be on the address pins coming out of the tester. The same with the data. So if you wanted to say FO, for example, not a very good choice, but anyway, you'll see it will change that, and the indicator will go down, indicating the data bus is now output. That's pretty much that. Bytes, that's to do with the block read and block write. So for example, if you want to set the address to 0000, so we'll go back to that. So we do our write address, you can see it changes to 0. Ignore the data and say we want to read in, say, FF for bytes, right? So we want to block read that amount of data. So you do block read, and what will happen is it says reading data, please wait, and after a short while it will come up with information, and the display will indicate the next address the tester will go to. So it doesn't matter what you type in there, unless you click write address, that will stay as it was set. So for example, if I did block read again, it will take off from that address FF bytes again. As you can see, it goes to 1FE, and as you can see, the data is put up onto that display there. So when